So we've got these types of children's activities. We've already been told here that x must be less than or equal to 15, and they've put that line there. And we've also got that y must be greater than 6. And part A says, why is that a dotted line? Well, it's because it's a strict inequality here, must be greater than 6. The next piece of information they've told you is that 3x must be greater than or equal to 2y. So we need a little table of values for that. So clearly 0, 0 is going to go through. And let's look what we got. Nice numbers on here. Look, well, 3 16s are 48 and 2 24s are 48, aren't they? So it's just going to be a diagonal line straight through those to figure out. That is where they equal each other. Which side do we want? And it's always sort of, I mean, obviously you can jump at one or the other, but look, let's just put, here's a nice point, 10, 10, and 3x's are greater than 2y's, aren't they? So we want this bit here. We don't want these bits here. So we'll shade that bit there out. The other piece of inequality we want, or the other inequality we want, is 5x's plus 4y's are greater than or equal to 80. And the 2 points we'll look for there, I usually go, well, cover over that one. So if x is 0, what's y? Well, y would be 80 divided by 4, which is 20. So 80 divided by 4 is 20 on the y-axis is there. I'll cover over that one, and 5x equals 80, so x would be 16. So that would be that one there. And we'll join those up. Again, thanks to the question, it's a nice greater than or equal to. We'll join those up there as well. And we want the total to be greater than 80. Again, if you're not quite sure, pick a nice point here. So, I mean, look, there's a point down here. Look, 4 and 2, clearly going to be lower, isn't it? So we don't want this bit down here at all. This bit here is too small. We want more than that. So we've got this little part here. So this is the feasible region that we're working with. There's a number of interesting points. That point there is where those two things meet. We've got a point up the top there. We've got a point in the corner there. We've got another point there. They're probably going to be where the answers are going to be. Where is that point there? Let's figure out where that actually meets. That might be the most useful one. I think if I just look, 2y is 3x, so 4y would be 6x. So I think it's meeting at 11x equals 80. So I think I've got 80 over 11, that's 7 and a bit, isn't it? Yeah, that looks about right there. So 7 and a bit as my x value, and that y value there is 10.9. And that looks like that meets about there, yeah. So 7.27, that's where they meet, 7.27 and 10.9. Now what we're trying to do is the minimize, the cost is 500x plus 800y, and if I substitute those two values in, so 500, lots of 7 plus 800 times 11. Clearly I can't have 10.9 because you can't have that many parties. That would make £12,300. Just check, I mean that is, I mean I'd now make sure, because I think 11, it is slightly to the side of that. I think that is in the feasibility region. I'd check that to make sure. But that is just that point there. So 1, 2, 3, 0, 0 would be that point there. What about this point here? So that would be 500 times, now you can't have, oh, that would be 11. 500 times 11 plus 800 times, you can't have 6. You'd have to go 1 up, 7. And that one, well, that's lower. And we're trying to figure out the lowest one. So actually, that one's better. Let's try this one here on the corner. Well, that's not going to be any more. That's going to be more, isn't it? Because it's going off to that side there. We could try it, though. So that's 15 and 7. 500 times 15 plus 800 times 7. That point there is 13100. I'm not putting 6 because it had to be more than 6. Up the top here, we've got a point there that's going to, I mean, this is going to be loads, isn't it? This is going to be 15 and 22. So 500 times 15 and 800 times 22. Clearly that one's going to be massive because it's right at the top here. But if we were trying to maximize, maybe that would be the answer. So I've tried each of these corners, and I think the minimum cost there is actually not the one I was working with. I think it's actually x equals 7, y equals 11 for a minimum cost of 11100. We talk about other ways of doing it, about putting a ruler on and then the ruler on here and then moving along. And yeah, maybe that is the first one it gets to before it gets to that as it goes parallel.